In the last video, we were introduced to greedy algorithms, and we saw that most of the time, they're not going to give us the right solution, but there are some cases where we will. Now, one thing that's important to note is that there's many ways that we can be greedy. We don't just have to have one thing that we are always going to be looking for. There's actually a few things we can consider, and I'm going to show you one problem where there's, I think, 3 ways that the greedy algorithm will not work, and then actually 1 way or 2 ways, essentially, that it will work. So the problem is, now I'm going to draw out a little timeline here, but I will erase this for the sake of the next examples. But this is just the problem that I'm going to have. Say I have this timeline, so this is the morning. Okay, maybe I should write it out instead of just scribbling it. I'll just write 0. So this is time 0, and this is some time t. Now I have a bike, and I want to lend my bike out to as many people as possible. Now I ask all my friends to send me their schedules, and these are the time frames that people want to reserve. So this is going to represent just people's times that they want to reserve the bike for. So this is just all the times. We see some are overlapping, they're all over the place, and we have all these times, and we have one douchebag who wants to rent it for the entire day. Now I want to give it to as many people as possible. That is the problem that I want to optimize. I want to lend my bike to as many people as possible. I don't care how long they have it for. I want the most amount of people to have my bike. Now we want an algorithm that's going to be able to determine what this is going to be. So how are we going to go about solving this? So I'm going to go ahead and erase this here. I've told you what the problem is because I'm going to present you with some ways that we're going to use a greedy algorithm to do this. Remember, the greedy algorithm is going to make the best possible decision for whatever we choose at every given point. And remember, if I show you one example where the greedy algorithm will not yield the optimal solution, then we don't even have to discuss it because it's not going to be worth using. It's not going to give us the right answer. We need our algorithms to give us the right answer. Okay, so just using logic, right? What would you think the best way to go about doing this would be, right? Well, I think picking the shortest events, the shortest intervals will give us the most amount of people using the bike. So pick the shortest intervals. Now we'll write out a little procedure over here. So we're going to pick the shortest. Pick the shortest one. We will cross off all overlaps. And then we will pick the next shortest that's remaining. Now, logically, this seems pretty good, right? Because the douchebag who wanted to rent the bike for the entire day is going to take up the entire slot. We'll only give it to one person. So if we pick the people who have the shortest times, that's probably going to give us the right answer, right? Well, you obviously know I'm not going to give you the correct way of using the greedy algorithm for this problem in the first example, because then I'd have nothing for you guys to look forward to for the rest of the video. So let's show you one example. That's all I need to do is show one example where this is not going to work, and then we don't have to talk about it. Well, let's say we have this little tiny time slot that somebody wants my bike for, and then I have overlapping the first part, we have this guy who wants it for the morning, and overlapping the second part, we have this guy who wants it for the afternoon. Well, let's go and we follow our procedure over here. We pick the shortest, so we will accept this little guy over here, and then that means we have to cross off the overlaps. Well, sorry and sorry. Automatically, just looking at it like this, we know that the optimal solution would have been to have 2 people using the bike, and we only had 1. So right now we can throw this option out of the way. There's too many ways that it could exist where picking the shortest intervals first will not give you the optimal solution. And I know it looks like I'm being really harsh on the algorithm, right? Because it seems like a really good idea and it might work, but you got to show that it can't work. If it shows, even if you just nitpick a lot and you show one example where it's not going to work, then this is going to be it. So I'm going to erase that because I will be coming back to this problem eventually. So that is one where it's not going to work. Well, okay, well, we see that overlaps are a bit of a problem. So, okay, let's use that to advantage. What if for our next, method of greed, we will pick the intervals with the lowest overlap? Right, that's going to solve our problem. So what is our procedure going to be? Well, number 1, we will start off by pick the least overlap. Number 2, cross off because you'll still have some overlaps. Cross off overlaps. Pick the next least overlap. I know it doesn't sound very nice, but it works. And this here, for this last point, we're obviously talking about the active overlap. So anything that you have crossed off, you don't need to worry about. So let's go ahead and show you why this is not going to work very well. So we have our timeline over here, and we are going to go ahead and we're going to have these, these 4 people, they got together and they decided they're going to split up the bike just like that. Then we have this one person who wants it in the middle of the day, and we have all these lemmings who want the bike at the exact same time for whatever reason. Remember, this might seem like a ridiculous situation, but as long as I can show one example, regardless how mean and how strict I'm being on that algorithm, if I show one example where it's not going to work, then it's just not going to be worth using this algorithm. So we're going to go ahead and follow procedure, pick the one with the least overlap. We see that all these ones here and all these ones over here are going to have a ton of overlap, right? So this one in the middle is only going to have, overlap of 2 other ones. So we're going to go ahead and pick it, which means we have to go ahead and cross off the overlaps. And next, we're going to need to pick one from these 2 little sets over here. So we're going to pick anything from here. So essentially, I'll go ahead and let's just say I'll pick this one. And that means I have to cross off all the overlaps. And then I pick the next one over here. Let's say that's how we were going about doing it. Obviously, all these have the same amount of overlap. So actually, these ones over here have more. So we pick the ones down there like I just did. So that's clearly not going to give us the right solution, because we can clearly see that there are 4 possible ones, those people who coordinated, right? We could have just done something like this. This would have given us 4. This is going to give us more people using our bike. So we have poked holes in this one. So, okay, so we're seeing what's going on here. There's still, a better way we can do this, I'm sure. So how about we go ahead and we pick the person who's going to start the earliest, right? So let's go ahead and do that. Pick the earliest intervals. Pick the earliest intervals. Now, I don't need to write out the steps for you guys, right? Pick the earliest one, then cross off all overlaps, and then pick the next earliest one. So that's what we're going to do. So let's go ahead and just show an example of this. Get the timeline. And let's say we have a bunch of people, right? We have a bunch of respectful people, right? Oh, look at all these nice people. They want to allow other people to use the bike, right? So they're just going to reserve little time slots. And we have the asshole who is going to reserve it for the entire day. And what do we do with this one? We pick the one that starts the earliest, which is this guy who wants it for the entire day. And all these people can go fuck themselves. Clearly not going to be the right solution, because we see that allowing all those people with the small time slots to have the bike will clearly allow you to have a much bigger quantity of people using it than having that one asshole using it for the entire day. Okay, so we have looked at a lot of them that don't work, and I'm going to show you 2 ones. They're essentially going to be symmetric, so it's going to be the same solution both ways. I'm going to show you 2 ones that are going to actually work. So for this problem, these are going to be the right answer. This means that you can use this greedy algorithm to get the best solution for this problem, which is a good thing, because in the last video we saw that besides the fact that the greedy algorithm normally gives you the wrong answer, which is a pretty big deal, if it gives you the right answer, you get to take advantage of the fact that it's quick, it's easy to program, and it's very simple, which is really good things. So what we're going to do, and I'm not going to bother drawing a timeline because I'm going to go ahead and use these examples that we just saw to prove it or to show it to you. We are going to go ahead and we're going to pick the intervals that finish the earliest. Pick the intervals that finish the earliest. Now let's go ahead and revisit these examples that we saw to show that we are going to get the right answer every single time. So here, pick the one that finished the earliest. This guy over here finishes the earliest. That means we go ahead and obviously cross off the overlaps. Then we go to pick the next one, 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 and we'll get the most amount of people using this bike. It's going to work. Let's see if I can get rid of all these here because I want to show you the next one working on these as well. Okay. Perfect. Let's go ahead and go up a level. We're going to do the same thing. Who is finishing the earliest over here? This guy is going to be finishing the earliest. So we cross off all those. Who is finishing the next earliest? This guy, cross off that. Who's finishing earliest next? This one, cross off that. And then this guy, we get the optimal solution of 4. It's working pretty well so far. Let's go and see if we can complete the sweep and do it with the last problem. And anything you're going to, give to this solution, it's going to work. This guy is finishing the earliest over here. Cross off this little guy. And then there you have it. You're getting the right answer every single time, which is awesome because this is so simple, right? We just need to look at one little thing and then we can just complete this process. It's so simple to program this and it's just going to work. Now, we can actually look at this another way and it's also going to work. I don't know if maybe I'll show you one example of it working, but this is going to be symmetric to this, which means it's going to give you the same results. It's going to give you the optimal ones. So instead of choosing the ones that are going to finish the earliest, we can essentially pick the ones that are going to start the latest, right? So pick the ones that start the latest. And this is going to give you the same thing. I'll show you one of those over here because this video is dragged on for a while. So pick the one that starts the latest. This guy starts the latest over here. So pick him, cross that off, and then you can you can see how the same thing is going to work. Over here, who starts the latest? This guy starts the latest, cross them off, pick all those right there. And then we see over here, who starts the latest? This guy starts the latest, cross him off, and then you have them there. And then you'll see that we still get the same answer for each time. So both of those are going to work, right? Both of those methods will work with the greedy algorithm to give you the best possible answer, which is awesome because greedy algorithms are a good idea if it would work, like communism. Let's end the video there. Bye.